So we are going to have a look on the intra-frequency handover. The intra-frequency handover procedure starts from measurement, but as I've mentioned before, there is no needs of the triggering, where the user is measuring the intra-frequency neighbors all the time. By default, the user has been measuring the neighbor of the RSRP and the RSRQ. So there is only one category of the intra-frequency handover, which is coverage-based handover. So event A3 must be used for intra-frequency coverage-based handover, where the user is going to send the measurement result according to the event A3 criteria. But the cells which are in the black cell list, which is the blacklisted cells, they are not going to be measured by the user. So the user sends the report to the init B according to event A3 criteria, and the init B has to make a decision according to the report. The reporting mode is called event trigger periodical reporting, where the first report is going to be sent once the criteria of A3 is met, but if there is no response from the init B, then the user will turn the reporting mode into periodical mode, where the user will be keep sending the same report over and over again according to the preset timer. Based on the reports which is sent by the user, it might consist more than one candidate cell. The candidate cells which is in the same init B with the source cell is having higher priority. So if not, then we have to perform a data forwarding, which it could be via S1 interface or X2 interface. So if the decision has been made by the source cell sends the handover request to the target cell, where the target init B has to perform the admission procedure. So the target init B checks the resource, whether it is sufficient for the new user, and to proceed with the signaling procedure execution with all of the handover acknowledgement message sent to the source cell, and to proceed with the handover execution. So if the first candidate cells reject the handover request, then the source init B is going to perform the retry mechanism, which is trying to send the handover request to the second candidate cells in the measurement report. So this is the screenshot of the measurement configuration, where the user is going to receive the measurement configuration after attachment. So right after attachment, init B send the measurement config in the message of RRC reconfiguration message. So this is the measurement configuration include all of the instruction for intra-frequency measurement, which include the event A1, event A2, and event A3 events. So the element which is included in the measurement configuration, as we have discussed earlier, there are three main important information. Number one, that is the measurement object. So measurement object is basically carrying the information of the frequency. So the measurement object to add mod list, which is the measurement object ID 1. So usually measurement object ID 1 is used for intra-frequency. So it carries the EARFCN of the particular frequency with the measurement bandwidth, whether the neighbors all carried one antenna ports or two, and the neighbor cell configuration, whether are they having the same configuration or not, the frequency offset, and this will be the list of the neighbor cells with has been set with higher measurement priority. So this is optional, where only the neighbor cells with high measurement priority or with the CIO not 0, then those cells will be included in the measurement object. The second information is called report configuration, where it is used to instruct the user to send the report accordingly. So for intra-frequency handover, event A3 is mandatory, where the event A3 offset will be included, the hysteresis is included, and with the time to trigger, the trigger quantity, report quantity, and the maximum report cells means the user is allowed to send up to 4 cells in one measurement report. where the user is going to turn the report into periodical mode, where the users will be sending the same report every 240 milliseconds and with the infinity number of the report. The third information is called measurement ID. Measurement ID basically it links measurement object ID and report ID. So we have seen the measurement object ID before, which is related to the frequency, and the report configuration ID that is related to the event. So one measurement ID link one object ID and one report ID. So user will use measurement ID in sending measurement report. So this is the filter coefficient, where the user is going to filter the measured RSRP and the measured RSRQ before sending it in the measurement report. So the filter coefficient by default, the value is 6. This is actually beneficial for the network in terms of the judging, as a stronger smoothing effect and a higher resistance to the fast fading is good for the decision, because from time to time the signal from the cell could be fluctuate due to the fading. So it is good to filter the measured value benchmark to the previous filtered value, so it creates a good smoothing effect. So this is the chart showing the event A3. Event A3 is being defined as the signal of the neighbor is greater than the serving. So to enter event A3, which is the measured RSRP or RSRQ of the neighbor cell, plus the frequency offset for the neighbor, plus the CIO cell individual offset between the source cell and the neighbor cell, minus hysteresis. So the total measurement of the neighbor signal is greater than serving, which is the combination of the serving cell RSRP or RSRQ, the serving frequency offset, the cell individual offset of the serving cell with A3 offset. So in a nutshell, it means the MN with all of the parameters is greater than the MS after some time, which is indicated by the time to trigger. So if it is intra-frequency handover, then OFN is the same with OFS. So they are going to cancel each other for intra-frequency handover. So the user has to send the measurement reports according to the format which has been predefined. And as we've mentioned, measurement ID is used. Measurement ID link the measurement object ID and the report ID. So the user is telling the input B the result of the RSRP and the RSRQ result of the serving cell and of the neighbor cell, the physical cell ID of the neighbor cell and the measurement result of the neighbor cell. So based on the reports has been sent by the user, then the input B has to perform filtering. The filtering has to be done in order to obtain the candidate cell, where the filtering is done by following the rules here, where the neighboring cells that have a different PLMN tag from the serving cell will be filtered, or the neighboring cell with a Handover prohibition flag, it will be removed as well. After removing the candidate cells as the previous slide, then input B rank the remaining neighbor list with the following priority. Number 1, the neighboring cell with the best RSRP or RSRQ value. Number 2, if the reports of few cells are the same, then the neighbor cells within the same input B is preferred. If not, then the neighbor cell which is not in the same input B, but it is in a different input B with the X2 interface available, it will be preferred as well. Then the input B sends the handover request to the target cell. So if the target cell replies with a negative acknowledgement, means a handover reject, then the input B will perform a retry, which is to send the handover request to the next target cell. So if the handover decision is made, then the handover execution will be performed, where the user is going to be handover from one cell to another cell. It could be from the different input B. So if X2 is available, then the data forwarding will be using the X2 interface. where the handover signaling has to go through the MME via S1C. So if the handover is between two init B without X2 interface, then the data forwarding has to go through S1 interface. So this is a typical handover flow where it starts from user receive the measurement configuration. Based on the measurement configuration, user has been monitoring the signal strength of all of the neighbor cells. And the user will be sending the measurement reports. And in intra-frequency handover, that will be event A3. Based on the reports received, the source cell is going to decide for a handover decision. It starts with the filtering, candidate cell filtering, and followed by candidate cell ranking. So after the ranking, the source init B send handover request to the target init B, where the target init B perform admission control first. If the admission control pass, then a positive acknowledgement is being sent to the source cell, where the source cell send the mobility control information to the user, which is the handover command. While waiting for the user to perform random access procedure to the target cell, the source cell performs a data forwarding to the target cell if there is X2 available. So the unsent data will be forwarded to the target init B. So if the user has been successfully completed the handover, that is a message called RRC connection reconfiguration complete. Then the target cell, target init B send downlink path switching to the MME, and the MME will be forwarding this message to the SGW. This is to switch the S1U and S1C. So after the path switch done, then the target init B send UE context release to the source init B, and the source init B will proceed by releasing the RRC and the radial barrier of this particular user. So that's all for the features and the parameters of intra-frequency handover in LTE.